Nanoscopic barcodes set a new science limit. Imagine shrinking barcodes 1,000,000 times from millimeter to nanometer scale so that they could be used inside living cells to label, identify, and track the building blocks of life. With that being said, hello wherever you are in any part of the world. Hello from my heart to yours. I'm just going to cover this a tad bit. Nanoscopic barcodes set a new science. And this is from Eureka Alert. You can go there. You can find this article. Do Eureka Alert. So what they're saying is they're able to label, using barcodes to label, identify everyday items. And they can shrink these barcodes to 1,000,000. They can shrink them 1,000,000 times from millimeter to nanometer scale so that they can be used inside living cells to track, label, identify the building blocks of life and or blend into inks to prevent counterfeiting. So hello, that's what I'm talking about. I'm not supposed to be on here, but I am. This is what they've done. And they have led collaboration, developed a nanocrystal growth method that controls the growth and the growth direction, producing programmable atomic thin layers, arbitrary barcoded nanorods with morphology uniformity. And the result is millions of different kinds of nano barcodes that can form a library for future nanoscale sensing applications. They said this will attract broad interest in a range of applications as information nanocarriers for bio-nanotechnology, life sciences, data storage once they are incorporated into a variety of matrices. Look, the inorganic nanobarcode structures are rigid and easy to control the composite thickness and distance accuracy between different functional segments for geometrical barcoding beyond the optical diffraction limit. They are chemically and optically stable, and the nanoscopic barcodes can be used as carriers for drug delivery and tracking into the cell. Now, they just say that they can make barcodes, nano barcodes that can go inside your living cells? Yes, they did. That's exactly what they did. It's breakthrough. This is a breakthrough with the development of a novel tandem decoding system using super resolution nanoscopy to characterize different optical barcodes within diffraction limit. Look at this. There is no commercial system available for this type of super resolution imaging. And this was written and it was released right here in November of 2020. This is very interesting. So look at this. Imagine a tiny device smaller than 1,000th the width of a human hair. That'll fit into you know what. that fit right into something that you can use. 1,000th the width of a human hair, and we can selectively activate a particular region of that device, see the optical properties, quantify them, and this is the science now showing many new possibilities. The researchers envision the developed nanoscale optical devices could be simultaneously used for tagging different cellular species. They're readily applicable for high security level anti-counterfeiting, and different batches of them are blended with inks. I'm sure they might be blended with other things, but could you imagine that? This is right here. Imagine shrinking the barcodes 1,000,000 times from millimeter to nanometer scale so that they could be used inside living cells to label, identify, and track the building blocks of life. That's all I have to say. Thank you so much for joining me. Have a wonderful rest of your day.